So, hello everybody. I had a little bit of a mishap connecting, so I'm glad we're doing this. Thank you for that introduction. Hello everyone. Welcome to HashiTalks 2024. The title here is to enable, integrate, and secure for very powerful platforms or tools, and I'm excited to share my work with you. Namely, the tools are Terraform Cloud, Vault, GitHub, and AWS. To reiterate, my name is Varnika Kaushik. I'm a cloud and DevOps engineer. I'm currently based out of Canada. I've got a whole bunch of things that I'm going to be covering in the 30 minutes. So I'm going to dive straight into the agenda for today. So the agenda for today starts with an introduction, aka what's in it for you. It moves on to the challenges presented by wanting to develop the solution, and past that we proceed to the solution overview. Basically, that's me explaining what I've done and how I've done it. And the solution has actually been divided into 4 sections, assuming first that there is no Vault instance at all, and then configuring everything to work with Vault. And then it moves on to a GitHub administration sort of demo. Everything's interrelated very deeply, so it'll start to make sense as to why they shifted to this. And it finally concludes with the deployment of some AWS resources using the setup. So let's get straight to it. I know, my audience is of varied levels, so I'd like to quickly call out the tools as to what they are and what they do. Terraform Cloud is an infrastructure as code management platform, so it centralizes your infrastructure as code practices. Vault is a secrets management tool. It's actually way more than that, but let's stick to that for the purposes of this demo. For large organizations, you have a lot of integrations. You have a lot of secrets going on. You have to store, maybe rotate. So you need something to manage them all centrally. That's where Vault comes in. GitHub is a super popular version control, source control, system, and it has fantastic CI/CD capabilities. And AWS, well, needs no introduction. It's one of the most popular cloud service providers that there exist. So, what are we going to do next? We're going to talk about what the solution, actually accomplishes. Well, firstly, it provisions Vault on the cloud. So, it deploys that. And then once you have this brand new Vault instance, you need to know how GitHub, AWS, and Terraform Cloud need to interact with each other, right? Along with Vault, of course. All of these components individually are great. How would they talk with each other? After that, it's a little bit of a showing off of, Terraform's fantastic capabilities, with its various providers, such as for GitHub, Vault, AWS, and in fact, for Terraform Cloud or Terraform Enterprise itself. The next part is to standardize your GitHub repos. And then finally, it shows you, how to deploy AWS resources using what are dynamic credentials, aka those generated on the fly for your Terraform-based deployments. Now, this really begs the question that, what kind of benefits does this kind of solution actually provide to my organization? And it would be valid, completely valid to ask that. Because you may be part of a platform DevOps SRE team, driving kinds of changes to sort of standardize development and deployment practices. You could be a developer frustrated with your current processes, trying to get more automation visibility. You could be at the managerial or the C-suite level, and you're probably setting some goals for getting more best practices introductions or meeting some, goals for all of the organization's business units. And regardless of who you are, a solution like this creates a unified, secure platform that'll help you achieve your goals. The solution can help adhere to best practices, of course, so it can create better development and deployment processes. However, one other thing that I'd like to highlight is that individually, the 4 tools are really powerful. But when you go into actually integrating them into a single platform, that can be really difficult. You need specialized folks with deep domain knowledge. Now, let's pause here and emphasize that it's not meant to say that I'm not meaning to say that you don't need them now, but that this solution is a way to help your engineers achieve results relatively faster than if you were starting, say, from scratch, right? Or say with nothing. As an engineer, security has to be on your mind at every point and step of the way. So the solution can help achieve a little bit of those secure connections between these tools. When creating such a platform, this unified secure platform that I'm talking about, which integrates these four tools, you're trying to enable developer productivity, and you introduce efficiency, probably likely operational efficiency, as one of the main concerns, right? So what happens is that one of the main issues that gets highlighted in all of this is that you should have it be simple enough to understand and use. That way it will be received better. Easier education equals easier understanding. Easier understanding means faster and better adoption. And therefore, I to emphasize, regardless of the goals you begin with, they can be achieved faster. So, with a solution like this, of course, there are multiple challenges that lie ahead. So, firstly, you've got these tools. How do you connect them to one another? What do you use to connect them? That isn't like 10 types of programming languages written in all kinds of ways. So, some legitimate questions to ask yourself, and especially your engineers, is how does GitHub know it has to talk to AWS? How does GitHub know it has to talk to Vault? How does GitHub authenticate to Vault? How does Vault know which secrets it should allow the GitHub repositories to access? How does Terraform talk to AWS? How does Vault know that it should generate dynamic security credentials for the AWS environment? And how should it send it back to Terraform when a GitHub deployment is triggered? These are some of the many questions that you have to ponder and then answer. So, with those questions in mind, let's just take a look at the solution, which is really the whole idea of this talk. So, how does it work? From an initial standpoint, it assumes you have no Vault instance. You have great ideas of using these four amazing tools, but you have no clue where to start. So it shows you how to provision the Vault instance in AWS. Now, the choice of deployment can be different for different use cases. I've chosen to do it on a single EC2 instance. You could, basis of your use case, that'll be different. So, in just a major disclaimer, the solution does not claim to be a one size fits all. You do need deep technical knowledge of various tools, the cloud, and so forth. Really, there is no substitute for that. It then creates some secure connections for you between Terraform Cloud, AWS GitHub, and the newly created Vault instance. It shows you how to use Vault to fetch secrets from your GitHub repository and to create dynamic credentials for your AWS deployments. As a show-off measure, it also shows you how to automate even your GitHub repository administration. Now, all of this is done using Terraform. With the various providers that Terraform has, such as for AWS, GitHub, TFE, or for Terraform Cloud itself, and a Vault provider. So, integrations like this can be really powerful, and they can usher in a whole new era of innovation for your organization. So let's delve into the solutions diagram. This is sort of like a pictographic idea of what is going to happen in the next sections. So I'm just going to very quickly go over it. Of course, there are multiple ways that you can authenticate to Vault, and they're called auth methods. And depending on your use case, you would want to choose one or more. There are multiple secret engines in Vault that can either store, generate, or encrypt secrets. We'll be using the AWS Secrets engine here to generate dynamic credentials on the fly. GitHub talks to AWS using OIDC, essentially using an AWS identity provider and an IAM role. Terraform Cloud talks to Vault using a JWT auth method or using OIDC. So I've tried to color code things, so I hope this is a little bit more easier to follow. Now, GitHub authenticates to Vault using another auth method called app-role, and then it fetches some big secrets. Vault talks to AWS using the AWS Secrets engine. Terraform's trusted workspace, and I'll delve into what it is later in the parts of the demo, knows it needs to use the credentials from Vault to run a deployment on AWS. GitHub to Terraform is using a Terraform API token. GitHub Actions are configured to run what is called a Terraform CLI-driven workflow, which uses the Terraform commands in a prescribed sort of workflow, which is the write, init, format, validate, plan, and apply. Apply being whatever Terraform configuration you've written can be applied to the environment after going through that workflow. So you're going to see me repeat that quite a bit as we proceed forward. Now, the environment could be your cloud service provider like AWS. It could be your Vault instance. It could be Terraform Cloud itself, or it could be GitHub. And I'm going to show you all of that. So hope you're with me. I'm now entering the demo side of things. So buckle up because this is going to be a little bit intense. So let's jump into the first part. It's on how to install Vault. I've chosen a single EC2 Amazon Linux instance. Again, it's a demo purpose, not suitable for production, so don't come at me. The code for provisioning the instance is using Terraform, and the CI/CD is using GitHub Actions. So let's dive into this. This is my Visual Studio code, and I have this repository called the Vault Provision. It's got all the Terraform code to provision Vault. I've written a template file that essentially is served into user data for EC2. I'm doing what a developer does. We just go ahead, create some beautiful code, add it, commit it, and push it. The rest of the process is taken care of by GitHub Actions workflows and different integration, some workspaces in Terraform Cloud and so on and so forth. We'll take a look into that as we proceed. So now that the change has been pushed, I've got these 3 repositories serving as, individual parts of the demo. So we'll dive straight into the Vault Provision repository. Here we have, again, Terraform-based code. There's already a GitHub Actions running because we pushed code onto the main branch, right? So I've got an on-push workflow. I've also got an all-on-pull request workflow. We're going to dive into that into sort of section 3, so hold on to your seats for that. So looking into the GitHub Actions workflow, we've got init, format, validate, plan. And if you wanted to take a look into the Terraform Cloud UI, you could do that. The workspace for this is Vault install. Big surprise, right? So you can take a look at the runs. Something called trigger via CLI, sort of the indication that you've used what is a CLI-driven workflow, right? So that's run. And we're now going to see, I've set it up to auto-approve, Terraform apply auto-approve. You're very welcome to not set it to auto-approve and have some manual, step that approves the apply process. Again, it's customizable, it's up to you. Okay, so now that that run is continuing, the plan shows you essentially what resources it's going to create and where. And once it finishes it, essentially it's going to move on to the next step. I created a Vault instance which has auto unseal with AWS KMS. It creates a VPC, it creates the Vault instance. It's also got a Vault public IP. Like I said, this is for demo purposes. You would never have your Vault instance on a public IP. You'd have your domain sitting very quietly in a private area, in a private sort of network, so that nobody can access it except the people who really need to. Having said that, we are now in the instance that we created. We've got some recovery keys. Let's set them as 5 and the key threshold for input as 3. We initialize Vault now. It gives us the root token and the key recovery keys. So we're going to download the keys and store the root token safely. And voila, we've got our Vault instance officially set up. Isn't that kind of cool? So now that you have it, what's the next step? We need to do a lot of configurations. You remember that solutions diagram? Well, now we need to execute it, and not manually, but using code. If you haven't guessed it already, it's all Terraform code. So to give you an overview of what is to be configured and where, in AWS, you need to create some IAM roles, the AWS identity provider that lets the GitHub repo authenticate to AWS using OIDC. Say you wish to update your ECS cluster, right? And after you've made, say, some changes to your Docker image, you don't necessarily need to jump through various hoops. You can directly talk to AWS. So that's an option. Again, all of these ideas are not the only option. They are an option. So you can always see what fits best for your use case. On the GitHub side, each of your repositories has to have a GitHub Actions workflow for Terraform. The state file or the source of truth for your deployments needs to be stored securely in your Terraform Cloud. So you initialize the backend using the API token from Terraform Cloud. You also need to store some secrets in your GitHub repository to be able to do so, specifically your cloud, organization in your workspace and the project that you have that you're going to be using. On the Terraform Cloud side, you have to use various workspaces, but most importantly, a trusted workspace, which is going to be initialized with specific environment variables to be able to use the Vault-backed AWS credentials for AWS deployments. Now, coming to the Vault side, AWS Secrets Engine does your bidding for the dynamic credentials part. The April auth method allows GitHub repositories to authenticate to Vault, and the JWT auth method allows Terraform Cloud to authenticate to Vault. I know that's a mouthful, but let's see an actual demo of that. So if you're with me so far, here's my brand new instance with nothing configured, except, well, let's presume I have enabled another secrets engine to store some key value pairs, right? And that's called KB. So the Vault version is 1.15.5. We've stored some, let's say, some keys. In my scenario, I stored a GitHub token and some Terraform API tokens here. There is, in full effect, a Terraform Cloud secrets engine as well, where you can generate those tokens on the fly. I haven't used it for the purposes of this demo. You're welcome to use it. Under authentication methods, we just have the token, nothing else for now. So we're going to actually do the configurations now through the Vault config repository, which has different modules doing different biddings. So some things that are going to run on the AWS environment, some things that are going to run on the Terraform Cloud environment, something that's going to run on the Vault environment. So getting into that, all of this code, by the way, Terraform. So with the various providers that we have, makes things a lot easier to do. Again, we've got the same Terraform CLI workflows for push and for PR. So as a developer, once you've set up all of this code, you go ahead into your repository. Maybe I don't like the variable description on one of my code. It's just to give you a random example, really. That's what it is. So that's what I'm going to show you. The workspace that I've configured for this is called Vault Configure. And that has a lot of these variables configured already. So that was done manually. And you're very welcome to use the Terraform provider to automate that as well. Maybe say create variable sets for your workspaces, even create the workspace itself. That's entirely up to you. I haven't done it, but you're welcome to extend the code as and how you feel. So now that the change has been pushed, now it's on the main branch, we're going to go back to GitHub. Obviously, the on push workflows triggered. Like I said, the Vault configure workspace is where we're going to store the state when we run all this Terraform code. You can check the runs here. Again, something's been triggered via CLI because that was the commit that we pushed, right? Again, the plan phase tells you something on AWS, something's on Terraform, something's on Vault will be created. There are specific outputs that are required for the next step, and those are going to be, that I'm going to highlight. So they have been set as outputs for the entire code. And once that run completes, we'll talk about it. Okay. So apply is pending right now. Cool. Love sitting and waiting and watching when it happens automatically. And just to emphasize, all I did was make a git commit and push the code to a Git repository. The rest of it runs on its own. It's like magic, but really, it's just really code. There's a lot of code. So now that that has run, we've got our AWS secrets engine. We've got the April and the JWT auth method set up for GitHub and Terraform Cloud, respectively. On the secrets engine front, we've also got something called roles, backend roles, that sort of authorize you to create the credentials. So, you can have a user type, you can have a role type, and so on. So there are three kinds. So once that is done, really, you are now officially configured everything. So what's the next step? Next step of the demo is that we do a little bit of GitHub repository standardization. We're going to initialize a new repository where, say, you want to push some Terraform modules for your AWS environment, right? So you need to initialize it with the right license. Maybe you need to create, some appropriate. You need to give some teams appropriate access to it. You need the right branching strategy for it. And so this section of the code, again, it's all in Terraform, does that for you. It's up to you how do you wish to use it. Extend it for your needs, modularize it, to help your corporate ID folks. Really, it's entirely up to you. This is just something that can, work. So this section is good. This is where we're going to initialize a GitHub repository with, a git ignore that has, Terraform related files that can be ignored, especially something like your, Terraform wars. Don't want that committed to your repository. It creates teams, it adds team to your repository. It creates 3 branches in that it creates feature, develop, and main for you already, so that at least when somebody starts using it, they have no choice but to use it. Sometimes you got to force these things, right? You can also have some branch protection rules, say on your main branch, which is probably going to your production environment. You could set it up for different branches, basis of what environments you have, and so on and so forth. Great. So we are now going to move to the demo section of it. So the GitHub admin setup repository. This is, again, something that I created. It's Terraform code. It has its own dedicated workspace, and like Vault configure, like Vault install, it's all Terraform code. It's got its own GitHub actions, similar CLI-driven workflow. You create some branches, you add some secrets to the repository that can be used by the GitHub actions. Those secrets essentially are also going to allow the Terraform AWS repository, which is not yet created but will be, to be part of your organization. And yeah, we're going to see more into what that repository, etc., is in a bit. It's going to be able to talk to Vault essentially to figure out some, to get some secrets if needed. So how do you configure that? I'm going to delve into a little bit. Yeah, let's just wait and watch. Same thing. We're back to our Visual Studio Code. Going to make some changes. Going to commit them. We're going to push them. As a developer, that's what you did. Now I pushed it to main. Again, don't put my head on a spike for that. I'm just demonstrating something. Cool. That action's been triggered. The GitHub admin setup has these 3 variables called app role ID, app role secret ID, and the Vault URL. These are required because they're going to be set as GitHub Actions repository secrets, and for the newly created Terraform AWS repository. And that's why they're there as part of the workspace variables, right? So again, we have something that has been triggered by the CLI with a push, of course. So it's on the planning stages. You can see the plan here. Again, if you wanted to go into the Terraform Cloud UI, you're welcome to. But if you don't want to switch to 2 platforms, the next section of the demo is going to really entice you. Okay, we're already on the apply stages, and we should be good to go. Yep, couple secrets, branches. I love it when it goes, voila, bam. It never happens this quickly. I just have sped up things here, but it does happen relatively quickly in comparison to if you were to do it manually. Cool, we now have 4 repositories. A public repository initiated with a Mozilla public license called Terraform AWS. We've got a little bit of a README. We've got the 3 branches, feature, develop, and main. We've also got those secrets, which I will show you in a little bit. For that, I think we have to go to settings. Yep, We'll go down to secrets and variables and go to actions. So that role ID, that secret ID, and the vault URL that we configured in the workspaces are now part of the GitHub repository. Because we're using a GitHub action to fetch the secrets from Vault, that's why these things are required. And again, we're using the app role method, auth method from GitHub. That's why also they're required, right? So phew. Now that the repository is initialized, you're eager to develop something. How do you do it? Well, the next section, I'm going to show you a little bit on how to create a simple web server in AWS, because by now we've done quite a lot of things. So it's going to be, again, a simple Linux instance, single instance, not meant for production use, but for demo purposes only. It'll show you how when a developer creates what is called a pull request on GitHub, the Terraform run pre-check happens. And that pre-check allows you to decide, especially as a reviewer, whether your code should actually be allowed to merge with, the branch that you're creating the pull request for. Should it be, let's say, for example, should the feature be allowed to merge to develop? If it's not a valid configuration, if it's not the planned stage, it doesn't look as expected. Maybe you want to, not allow that merge to happen. So without spoiling the rest of the fun, I'm going to get into the demo. Again, we're back to square one with the Visual Studio Code. You've got our beautiful code you've developed. You've taken out the time to, retrieve those secrets from Vault. You've taken all the beautiful pain. But you think I need some more changes. You push some code. Same process. You add, you commit, you push. Now remember, this is on the feature branch, right? So pay attention to that, because the next step is going to be crucial. So now that you've pushed a feature, let's create a new pull request. I'm confident, that my code runs. I've done some tests and everything. So I'm going to try and see if I can merge it to develop. So same sit. I'm pretty sure most of it is familiar to a lot of you. Here you're going to write, well, what changes you're going to put in. You can always make the changes according to whatever your, whatever honestly you need to put in the pull request. It's up to you. Or how stringent your requirements are by your reviewer, really. It depends on that as well. So here's something awesome is going to happen. You created a pull request. I talked about a pre-check, but what does that pre-check really look like? The pre-check is a GitHub Actions workflow that triggers on a pull request. It goes all the way from Terraform init to Terraform plan. And then there's something really cool that happens, which I'm going to show you once that's done. So once we attain that plan stage, essentially you're going to get an output of the run into a comment on this PR. Just to reiterate, Vault-backed AWS Auth is the workspace that is the trusted workspace. It's got all of the necessary environment variables that we create, some of these values came in from the previous run and then that workspace was created. On the AWS environment, we just have that Vault instance. We have really nothing else as of this point, but we want to create a web server instance, right? So yeah, let's see if this has succeeded. Yeah. So you see that comment? It gives you a failure or success on each. You can even, view the plan there instead of having to toggle through, Terraform Cloud and back and forth. You can do that. Choice is yours. This is something cool I picked up off the internet. So once you say you like what's happening, you approve it, confirm the merge. You actually merge the feature branch into the develop branch. You're welcome to delete the feature branch if you like. And then another action, basis of the fact that you merge the feature code into develop, gets triggered. Now this is going to go all the way to the apply stage. So you are not essentially triggering something after you've merged the code. There is a GitHub Actions that is triggered automatically, which is going to use this workspace to trigger, first a speculative plan because we ran Terraform plan. And then when you do a Terraform apply auto approve, it's going to go through the same process again. Now, I know that seems a little bit of redundancy. You can always remedy it, remove the auto apply, save the Terraform plan as TF plan, and then pass it to the next step as well. Welcome to try different combinations, see what works best for you. Cool. Now that the apply is running, this is going to just create, this is a very simple code, creates a VPC, creates an EC2 instance, and then that's all. So let's see, on the AWS environment, we have a web instance now that's called a web instance. It's under a web VPC under the public subnet. This kind of concludes the end of my talk. I know we went through a lot of things, so kudos if you stuck around for so long. There will be plenty of questions, plenty more suggestions and improvements. All of it is welcome. I will be sticking around in the YouTube chat after this talk to answer, clarify for you as much as I can. But if in the scenario that I can't, here are the QR codes to my LinkedIn, my Medium blog, and I will soon make all of the code for this talk public, so you can read and dissect as much as you want. There are going to be several blogs, by the way, following this talk, and I hope you find the time to read them on my Medium. Again, if I cannot answer any questions immediately in the chat, please feel free to connect with me over LinkedIn. I'll do my best to get back to you as soon as you can. Thank you so much for your time. I hope you find this talk useful. See you around. Cheers.